Hi everyone. We are going to discuss here problems on logarithm of complex number. So let's see. So guys, it is very easy concept you have to discuss here today. So let's see. In this discussion, we have to discuss about introduction, discuss about what is actually logarithmic function and what is a problem is there. Let's see. Now we are going to start here. So if we think about the logarithmic of complex number, let I'm considering here z and w are two complex number. Okay, so I'm taking here first definition of this logarithm of complex number. Let if z and w are two complex number, two complex numbers, and I'm writing here z is equal to e to the power w, guys. Z is equal to e to the power w, then that implies w is equal to what is that here, log z is here, guys, log z. So is called logarithmic of complex number z. Okay, is called logarithmic of complex number z. So what is complex number? So notation is what is that, z. Now let's suppose I'm considering hearing z is equal to what is that here, x plus iy. X plus iy, this is in Cartesian form, guys, and if you have to substitute x is r cos theta, y is r sin theta, then it will get the complex number in exponential form as r into e to the power, guys, I theta. Okay, so where you know that very well, where what is r and what is a theta, guys, where r is equal to, this is under root of the x square plus y square. This is called as modulus of a complex number, guys, and theta is called as amplitude of complex number, and this is given by, this is a tan inverse of, this is y by x, guys. This is tan inverse of y by x. Now I'm going to discuss here log z. Means what is that, logarithmic of complex number, log z. And log z can be written as log of, what is the value of z? Z value is r into e to the power I theta. So I'm taking here r into e to the power what, I theta, guys, r into e to the power I theta. So by using logarithmic property, so this is product of two terms, means this will get log of r plus log of what is that here, e to the power I theta, guys, e to the power I theta. So this can be written as, this is a log r, guys, plus e power can be written as I theta into log of e, guys, and you know that log of e is what is that, 1. So therefore remaining is what is that, log of r plus I into theta, guys. Okay, now since log of e that is equal to what, guys, 1. Okay, so therefore log of, guys, z means what is that, x plus iy is equal to log of r means what is that, this is under root of x square plus y square, guys, plus I into theta is nothing but, guys, it is a tan inverse of y divided by x. So this is called principal value of log z. Okay, so principal value of log z, guys, this is a principal value of log z. Okay, now further we are going to discuss here what is further we have to going discuss about what is the value of, or what is the general value of log of z, guys, this general value of log z. Now let's see, the general value of log z can be written as the general value of log z is given by, guys, so this is a log of, this is notation is a capital log of, now x plus iy, and that is equal to, so formula is, this is a log of r, that is means principal value r plus I into 2n pi plus theta, guys, 2n pi plus theta. You very well known log r means 1 divided by 2 log of here x square plus, guys, y square, x square plus y square. plus I into, now I am taking in the bracket is here 2n pi plus theta is, what is that? Theta is called amplitude of complex number. This is nothing but this is a tan inverse of y divided by x, guys. This is a tan inverse of y divided by x. So therefore I am writing here, therefore this is what 1 divided by 2 log of x square plus y square plus tan inverse of, that is a y divided by x, and plus I into means I tan inverse of y by x plus remaining is, what is that? Here is a 2I n pi is there, guys. Okay, you observe this value, now this value is, this is a value of principal value of complex number, that is a log of x plus iy plus I into 2n pi, guys, and this is a log of x plus iy. So guys, we have to also here, you observe this very carefully, this is also relation between principal value and general value. Okay, so this is called general value of, general value of complex or logarithmic of complex number. It is called a general value of log of z, guys. Just I am writing here general value of log of z. So simply you have to remember this, guys. Remember this, guys. So the notation log of x plus iy shows that it is called as, it is a principal value, guys. It is a principal value of log of, and second notation uses capital log of x plus iy, it is called, guys, it is a general value. Okay, you noted very carefully this. Now understood this, all of this, guys? Okay, now we are going to discuss here problems on, that is a miscellaneous problem on logarithmic function, guys. Miscellaneous problem on logarithmic function. So let me start the problem, guys. Let me start the problem. Let's see. So prove that. Okay, so problem number 1, prove that log of cos x minus y upon cos of x plus y is equal to, bracket complete is there, guys, and that is equal to 2I tan inverse of, in bracket, tan x into tan hy, guys. Tan x into tan hy, guys, means hyperbolic tan y is there, guys. Hyperbolic tan y. Now this is very easy question. You have to simplify here, guys. You have to concentrate very carefully. Because of that, you have to use here logarithmic function on complex number. So let's see. I am taking first LHS. Let I am writing here, that is a log of cos x minus iy divided by cos x plus iy. This can be written as by using logarithmic property. So this is a log of cos of x minus iy, log taking separately, so this will get a minus sign is there, minus log of cos of x plus iy, guys. Okay, so combinedly it will get log of cos x minus iy upon cos x plus iy. Here we have to use which log property is there, guys? Which log property? Since I am taking some reason is there. So for example, this is for references equation number 1, means log of a by b is equal to log of a minus log of b, guys. Okay, now let I am considering, let also consider what is that? Only cos of, means only this first log of cos x minus iy, guys. Okay, log of cos x minus iy. So this can be written as, this is a log of, now x minus iy means what is that? Here we have to use the cos of a minus b formula. Here we have to use the cos of a minus b. So this is what, this is a cos x into cos iy. Now this minus, it becomes plus sin x into sin iy, guys. Sin x into sin iy. Okay, so we have to use the formula for cos of a minus b, guys, is there. Okay, so after simplifying this will get log of in bracket this is a cos x into cos iy is nothing but cos hyperbolic y guys. Okay, now plus that is a sin x, sin iy means here I sin hyperbolic y guys is there. Okay, so since we have to use here cos iz is equal to cos hz and sin iz is nothing but I into sin hz means hyperbolic function into z is there. So you have to using this result guys. Okay, so therefore for consideration, therefore this is a log of guys I am taking here a plus b, a plus I into b guys. I am for consideration this is only cos of a plus ib. So where what is the value of a is nothing but this is a cos x into cos hy means hyperbolic y and b is equal to there is a sin x into sin hyperbolic y guys. So therefore you know that the principal value of cos of x minus y means this is nothing but this is a log of complex number, right? This is a plus ib. Okay, so next what to do here? So therefore we have to getting clearly, therefore we have to getting this is a log of cos x minus y. So what we have to getting here, I am considering log of a plus ib guys, a plus I into b. If this is x plus iy then we have to write this, we have to write it's a principal value guys. So principal value means this is 1 divided by 2 log of that is in under root sign capital S square plus b square plus guys I into tan inverse of I into tan inverse of b divided by a. Okay, so this is a log of cos x minus iy values guys. Okay, for references we call this is equation number 2 guys. Okay, so similarly you have to write again log of cos of x plus iy. So this can be written as, so there is a difference, minus and plus is there, so minus and plus. So I am writing the formula from equation number 2 as this is again 1 divided by 2, this is a log of under root a square plus b square guys. Now this will get plus is there, now I am taking here minus because of that there is a change in plus and minus sign. Here is a minus, there is a plus, here is a minus, there is a plus, here is a plus, there is a minus. So I am taking the similar term is here. So therefore this is a tan inverse of this is a b by a guys. So this is equation number 3 I am taking here, this is equation number 3 for consideration is there. So therefore your equation 1, therefore equation 1 becomes guys, equation 1 becomes, so what will you get equation, your equation 1 as this is a log of, your equation 1 as this is a log of cos of x minus iy divided by cos of x plus iy, and we can written now is in this form, this is a log of cos x minus iy, right, minus log of cos x plus iy. So bracket completed this guys, and therefore this is equal to, from equation number 2 and 3. Okay, what is the value of log of x minus iy? This is a simply this is 1 divided by 2 log of under root a square plus b square, right, plus I into tan inverse of b divided by a. Next, minus of this value, I am taking minus sign to this value, so minus this will becomes 1 divided by 2 under root of, will get tan inverse of means under root of a square plus b square guys, under root of a square plus b square, under root of a square plus b square guys. Now minus minus there will be here plus guys, minus minus there will be here plus, because of this term is a minus and term is here minus minus plus here I tan plus here I tan I tan inverse here b divided by a guys. So what is the remaining is there guys, this plus 1 by 2 log under root this plus 1 by 2, this same term plus or minus, therefore it cancel with each other, and I tan inverse b by a plus I tan inverse b by a, it becomes 2 times tan inverse b divided by a, guys. Okay, so this is a log of cos x minus iy upon cos x plus iy, but this is not your actually RHS, guys. So I am taking again, this is a 2 into tan inverse. What is the value of a and b, guys? So let you see what is the value of a and b. Okay, let's see this. What is the value of a and b? A is a cos x cos y, and b is a sin x sin y, guys. So therefore resubstituting a and b, a is cos x cos y cos hyperbolic y divided by sin x sin hyperbolic y, guys. So this is a b divided by a, guys. So that's why I'm taking here ratio is in now in this way. This is a b divided by a, guys. Okay, so therefore what is a b, guys? B is a sin x sin y, that is a sin x sin hyperbolic y divided by cos x cos hyperbolic y. Okay, and after the again resubstituting this, this is a 2 into tan inverse in bracket sin x upon con x, this is a tan x into, that is a tan hyperbolic y is there, guys. Okay, so clear up to this? Yes. Okay, so what is the remaining is there, guys? Okay, so therefore we have to taking here what is the remaining term is there, means what is remaining. So this is a log of cos of x minus iy divided by cos of x plus iy. Remaining is there, what is that? This is a 2i tan inverse of, remaining is a tan x into tan hyperbolic y, guys. Okay, and hence the proof, and hence the proof, guys. Okay, hence the proof of your question. Okay, I hope you understood and enjoyed this example. Thank you.